Good day everyone, we are the proponents of the case study entitled Proposed Counterfort Retaining Wall Design along Kibawe, Kadingilan, and Kalilangan Road, a comparative study. I am Cedric Moral Pahilan, together with
Ridel Ayad Vincula,
Jennifer Di Mapitan,
Brent Gio Moncay,
John Albert Siamper,
and we are the Road Masters.
Retaining walls are crucial for stability and erosion, prevention and slopes. They're used in areas with unstable soils, steep slopes, or high runoff. They protect roads and structure from washout and preserve the environment and water quality. Safety factors are essential to prevent failures and support the backfill ground. So our case study analyzes the design and construction of the reinforced concrete retaining wall for slope stabilization in Kibawe, Bukidnon. It aims to prevent accidents caused by heavy rain, landslide, or mudslides. We'll examine key factors like risk, stability, reinforcement, and a model of wall to gain insights into its effectiveness and safety. So for the current condition of our case study, the soil around the retaining wall is saturated sandy silt mixed with rocks, which can affect drainage in soil stability. Despite these challenges, the recently built retaining wall is in excellent condition. Its design and construction adhere to the latest engineering standards, ensuring structural integrity. To maintain its performance, long-term factors like soil settlement, groundwater levels, and external loading need to be monitored. Regular inspection and maintenance are essential to address any potential issues, ensuring the wall's durability and resilience over time. For project location, the Kibawe Kadingilan Kanilangan Road in Bukidnon, Philippines, specifically the Rumagok site, has experienced slip slope, collapses, and landslides. This site is located in the municipality of Kibawe within the province of Bukidnon on the island of Mindanao. The coordinates 7.5780 latitude and 124.9540 longitude mark the exact location. These geological events emphasizes the need to study and understand the site's conditions, as well as implement measures to ensure safety and stability in the affected area.
Now for the limitations and fieldwork of our study. Data used limit only to the available resources given by the DPWH 2nd DEO Don Carlos Bukidnon. This study compared the existing mechanically stabilized retaining wall with the proposed counterfort retaining wall within the municipality of Kibawe. Specifically, the study focused only within the area of Rumagook, Bukidnon. Furthermore, study compared the two types of retaining walls in terms of their stability analysis, appropriateness of design with the current soil stratigraphy, and overall performance. The study was expected to be completed within this month. During the fieldwork, a visual inspection was done, identified cracks, bulges, and signs of distress with careful documentation of their location and severity. Dimensions of the wall were measured to aid structural analysis. Material assessment included identifying construction materials and potential lab testing. Groundwater conditions were evaluated by the help of existing data. Soil sampling and testing was also determined by the existing data. Adjacent slopes were analyzed for stability and erosion, considering vegetation and other factors. Drainage effectiveness was assessed to prevent excessive pressure. Field observations were documented for analysis, adhering to safety protocols.
soil stratigraphy at Rumagok, Kibawe, Bukidnon was mainly stiff to hard sandy silt and silty tuff layers, which indicates low susceptibility to liquefaction during a magnitude 7 earthquake. In addition, Tables 3.3 and 3.4 are the summary of idealized geotechnical parameters, which consist of unit weight, saturated unit weight, angle of friction, cohesion, and modulus of elasticity of soils with respect to its different classifications. Visibly seen on both tables that the soil is cohesionless. The geotechnical investigation also found out that there is a water table at a depth of 12 to 12.5 meters from the surface. Meanwhile, Table 4.1.1 summarizes the structural analysis of counterfort retaining walls and MSE retaining walls. The result signifies that the counterfort has a satisfactory performance for stability analysis, bearing capacity, and dimensional analysis. Though both designs are satisfactory, when compared to the MSC wall design, the counterfort retaining wall has greater factor of safety value in overturning and bearing capacity than the MSC wall.
And now for the structural plans and details. Figure 1 shows the plan consisting a 60-meter proposed counterfort retaining wall which is at K1585 plus 280 to K1585 plus 340 located at Barangay Rumaguo, Kibawe, Bukidnon. The details are somewhat unclear for you, but it is shown in the figure that there is an existing stone masonry slope protection which is located at the roadside of the end of the project location at K1585 plus 340. On the other hand, figure 2 shows the cross-section and the isometric view of the proposed counterfort retaining wall, and as we can see, the parts are labeled such as the stem, heel, toe, the counterfort, and the finished ground line or the FGL. Meanwhile, figure 3 depicts the cross-sectional details of the proposed counterfort retaining wall, in which it shows the location of the FGL or the finished ground line, which is at 3 meters above the base of the structure. Moreover, it also shows the width and the height of the base, width of the heel and toe, height of the stem and the thickness at the top, and the height of the structure, which is at 8.80 meters and 1.5 meters, 4.85 and 1.75, 7.5 and 0.7 and 9 meters respectively. On the other hand, the figure also specifies the diameter and the numbers of reinforcing steel bars that are needed based on the dimension in designing the counterfort retaining wall using the GU5 software, in which upon designing, it is based on whether it satisfies the condition provided by the software. So far, the following reinforcements satisfied the given conditions. For the next slide, Figure 5 shows the catch basin details of the proposed drainage outlet or the retaining wall and its corresponding isometric view, in which it also shows the detailed specification along with the reinforcement details and the cross-section of the catch basin. On the contrary, we have here the MSE wall plan designed by the Department of Public Works and Highways, 2nd District Engineering Office at Don Carlos, Bukidnon, in which we had shown on the previous slides our proposed counterfort retaining wall plan, which was adopted by this design. In addition, the mentioned catch basin was also adopted from this plan, in which it is needed since there is an existing drainage that intersects along the highway, which connects the slope that was utilized in this plan for the rehabilitation or reconstruction of slip slope collapse and landslide protection.
Based on the analysis and comparison between the existing MSE wall and the proposed counterfort retaining wall, it is recommended to proceed with the construction of the counterfort retaining wall design for the specific location along the Kibawe, Kadingilan, Kalilangan Road. The inclusion of counterforts provides additional structural stability to the retaining wall by reducing bending moments and shear forces along the wall. This design feature enhances the overall performance and load-carrying capacity of the retaining wall, particularly in situations where there are significant surcharge loads and potential for seismic events, earthquakes, landslides, or other earth movements. The result of the study was limited by the available data and resources provided by the DPWH 2nd DEO, Don Carlos, Bukidnon. The researchers encountered certain challenges throughout the research process due to these limitations. However, despite these limitations, the study successfully presented a comprehensive comparative analysis between the existing MSC wall and the proposed counterfort retaining wall design for the specific location along the Kibawe, Kadingilan, and Kalilangan Road. In conclusion, the research supports the adoption of counterfort retaining wall design over the existing MSE wall for the specified location along the Kibawe, Kadingilan, Kalilangan Road. The design's incorporation of counterforts significantly enhances structural stability, load carrying capacity, and adaptability to varying soil conditions. By complying with the ASHTO guidelines and conducting thorough structural analysis, the proposed counterfort retaining wall design will ensure long-term performance and mitigate potential risks associated with soil variability and external forces.